Hello and welcome to this UniTaster On Demand event today. My name is John Sheik. I'm here from UniTasterDays, and it's my job to introduce the event and introduce the speaker. The subject we're going to be looking at today is software engineering, and I'm absolutely delighted to be joined by Dr. George Bargiannis, joining us from the University of Huddersfield. George is a subject area leader for computing and information systems, and is going to provide a guide to why you might want to consider studying software engineering, what to expect on the course if you do study it, maybe some application tips and some career tips thrown in as well. But with that, I'll pass things over to George to provide an overview to studying software engineering at university.
My name is George, and I'm the subject area leader for computing and information systems at the University of Huddersfield. In this talk, I will take you through the basics of what software engineering is about and what it looks like when you're studying it at a university. So software engineering is usually considered a part of computer science, but it is in and of itself a separate subject which has had a major effect in the world. Now, I happen to know a lot about it because it has been part of my journey so far. So I began with studies in electronic and computer engineering, but then moved on to computer science with a focus on building software engineering projects. And then after my studies, I moved on to research in fields that include computer science, so artificial intelligence applications with a software engineering element and building software that improves the lives of people around the world. So in the presentation today, I will give you some of the examples of the ways that software engineering can improve the world, really. So we'll begin with a kind of a definition. Now, software engineering is a particular side of computer science, but it has its own individual characteristics. So we'll look into that. We'll look into how software engineering and its applications have shaped the world we live in today. Then we'll go on to discussing how it is to study software engineering. Why would you go down that path at university, what kind of modules you're going to study, and so on. And then a little bit of a set of application tips to help you out in preparing to apply for software engineering at the university. At the end, I will give you a little bit of statistical information in terms of jobs that you can get graduating as a software engineering, companies you can work at, and in general, how easy it is to get employed after uni as a software engineer, and how well you will be compensated. So let's begin then with definitions. So software engineering, obviously, two words, software and engineering. The idea here is to build software systems, build software that runs on code, on programming code. Now, what has happened in recent decades is that everything around the world relies on an element of software, some kind of program that is designed and developed by humans to allow systems to operate. So you would have software running on every mobile device, your phone, your tablet, your laptop. They can't work without software. But then you have transportation systems, airplanes, trains, cars, all of them running an amount of software to make things faster. So you would have a software processing unit in your car that takes information from the surroundings to let you make the right decisions and be safe. You have software in space, in satellites, in spacecrafts, helping astronauts conduct their research. You have software on medical devices, so lives actually depend on software running in the right way. And then you have a range of smart systems operating inside buildings, homes, factories to help advance work in these settings. So in this setting, you have software running behind pretty much everything that a human is involved with. And in today's world, software is behind innovations like the vaccines we've seen, the track and trace systems that we're following, everything that humans had to throw at the virus that we've been fighting was powered by software. So the idea behind software is more than 6 decades old. It was coined by actually a NASA engineer in the US. And the idea was, if we're using a certain way, an engineering way to build a bridge and to build it in a robust and appropriate way, why shouldn't we follow the exact same path, the exact same process to build software? It's not a bridge, but still it relies on the same features. So for example, you would need to build a bridge that would meet passenger needs in terms of safety, in terms of time in transportation. Well, in the same sense, you would need software that meets the exact user needs. So software that provides functionality that helps your users and keeps them safe in certain settings. Then you would need a bridge to stand strong as long as possible, obviously, but you would also need software to be active and operating for as long as that system is necessary, until a new system is built to replace it. So you need that longevity for software the same way you need it for a bridge or any other structural building. Then time and budget are very important in terms of engineering projects like bridges. Well, it's the exact same thing with software. You need your software to be delivered on time. You need it to be on budget. Otherwise, you would have dissatisfied clients, users, and obviously companies wouldn't be able to cope. So it's that idea of transferring all of the work that was done for years, because engineering as a discipline is far, far older than software. It's transferring these knowledge all the way to software. And that has led to a revolution, I would say. When software engineering was defined, it was still not clear how we can build good software fast. Nowadays, we have made it into a world where we can do that and we can use software to change people's lives. So I have next a video from a professor in the UK who has linked their name with software engineering, Professor Ian Somerville, to explain a little bit about how software engineering is shaping today's world.
I'm Ian Somerville, and in this video I'm going to explain why software engineering is so important to our lives in the 21st century. Put simply, software is everywhere. Our society is totally dependent for its efficient functioning on software-intensive systems. Our infrastructure, power, telecommunications, transport, the financial system are all dependent on software. Governments could not collect taxes without software, and we could not run our businesses without the whole host of software-intensive systems that are used. Software has taken us into space. It has created the World Wide Web, which has led to transformative applications which have radically changed the lives of many people all over the world. Dealing with the problems of the 21st century can only be done with software-intensive systems, so we will need more and more software as the century goes on to help us cope with these problems. Problems such as climate change, as the average temperature of the world increases. Feeding and housing a growing world population. Coping with the problems that come from people living longer and providing a high quality of life for our elderly citizens. And dealing with international terrorism, a scourge on all of our societies. We need software engineering efficient and effective techniques of developing complex software systems.
Ian Somerville described a world that is running on software, a world that operates with software in every step of the way. Another quote that I really like from Bob Mulia in Microsoft is, software powers the world. So that means that software developers are the engine behind what powers the world. And that couldn't be more true. Without software engineers, a lot of things that we are doing nowadays in our everyday lives would not be possible. So all in all, what software does and what software engineers help us with is they help us achieve things faster, easier, and better. So by becoming a software engineer, you're becoming part of that change, part of that engine that powers the world. So why would you go on to study software engineering at the university level? Well, I have three main reasons for you. First of all, it's your ability to learn how to think algorithmically, so how to build algorithms that can solve real world problems. So all of the problems that we saw before, you can solve them through software engineering. But at the same time, what has changed in recent years is that software is also relying heavily on information and data. So we collect data and we use them to drive software engineering development. So you will also learn how to store data, manage it, process it, and analyze it. Then it's an opportunity for you to innovate, to develop projects either on your own or within a team that enable the use of software in any setting for any application. And you will be able to explore ways to engineer software, optimize them in terms of runtime or in terms of cost, and what has become very important nowadays, how to keep software systems secure, how to prevent your software from being attacked by hackers and cybersecurity threats. So the third part is you can use your software engineering studies and the career that follows to build the future for yourself. So employability in this field is very, very high. There are a vast number of sectors that require software engineering skills. So you would be able to work in a wide array of companies that have some element of software built into them. Salaries are competitive just because of that need of software engineers nowadays, and your prospects are wide. You would be able to advance your career and progress gradually as your skills become stronger. The other thing that is good in this job is flexibility, especially nowadays in a post-pandemic world. A software engineer needs only their system to operate. So they just need a laptop, they just need a system where they can write code, develop it, and test it. So you would be able to work everywhere you are. You don't need to be in an office to do that. And that also, including other reasons, has led to high satisfaction rates for people who are employed as software engineers. So you would be able to do the job you love, I hope, and be compensated for it. Now, if you were to go on and study software engineering at university, you would find that the modules revolve around what we call the software engineering's life cycle. So this is the process that we follow for any software we're trying to build. And we go through those steps a number of times as long as it's necessary to build good, robust software. So we would start with planning a solution, analyzing the requirements of the client, design a solution, implement it using a programming language, test it to make sure that it works, and maintain it to make sure that it works for as long as it's necessary. And then we'll go into that loop again for the next version and the next version of a software. So all of the modules in a software engineering course at university help you gain skills across all of these 6 phases in the life cycle. So you would have obviously coding modules, learning languages like Java, Python, C++, HTML, CSS, a vast array of languages available. But what you need to keep in mind here is that just knowing one language would unlock any other. So you don't need to learn all of them at university. You would be able to branch out to others when you are employed. You have modules around requirements, how to collect requirements, analyze them, and build a product specification out of them. Architecture, how to put the building blocks of software together to make a whole. Algorithms and data structures, how to think algorithmically and use data to drive software solutions. Databases, how to store data and query that data to gain insight into extra knowledge. Test and maintenance, very important aspects of software engineering. It's one thing to build software, and it's another to make sure that it works for as long as it's necessary and that it satisfies your client's requirements. That's a very important bit, and every software engineering course includes that in it. Secure software. In a recent development, a focus on keeping our software systems safe and secure from attacks. This also features in the course. And a niche area is large-scale software engineering, where you look at the software engineering lifecycle and scale up to millions of lines of code, million users, and software that runs globally, software that everyone uses in every corner in the world. So in that case, you need some different skills additional to what you've learned in standard software engineering to be able to deliver those large-scale projects. At the same time, you would be able, in a software engineering course, to hone your skills in projects. So you would carry out projects either on your own or as part of a software engineering team, kind of simulating the way it would look like once you go into employment. So as a student, you would be able to take on roles in a real software engineering team. So you could become a tester, you could become a designer, a coder, and collaborate with your fellow students to deliver a software solution. In some cases, that could be with real clients who can present a problem for you to solve, and you and your software team at university solve it. So you would need to plan a solution, design it, develop it, test it, and deploy it and present it to your client. There's also the opportunity to go on placement that would give you a year out in industry to work either in a software development company, meaning your day-to-day job would be to develop software for a company that sells software products, or you would be able to work in any company that is in need of software engineering skills. And I can't think of any sector where a software engineer wouldn't be necessary. So there are plenty of placement opportunities to go there after your first 2 years of study. Now, some tips for your application. It's very important, first of all, to do your research. And that means looking at different courses at different universities, checking their entry requirements, understanding the differences between different courses, and also research around the subject itself. So I have given you some information, but there's vast information online around understanding the discipline, the different skills necessary, and the different applications that come out of software engineering. So you need that research because that would make you more knowledgeable in writing your personal statement. And your personal statement not only needs to be knowledgeable to show that you are aware of the sector, but you need to show passion in it, because that makes it different to others. And you show passion in three different ways. One way is to give examples of your experience, your personal experience and interests that are linked to software engineering. So you can mention, for example, having worked in a school project that involved researching software or even building software, if that was your pathway. You could talk about projects of your own. So you are keen to learn about software, so you have done your research and you have prepared small projects to kind of test the waters to understand how software engineering looks like. So any example like that makes your application different to a standard application. Then if you cite your personal reasons for choosing the course linked to those interests that you might have mentioned earlier, then that shows to the academic that this is a path that you're choosing because it's linked to your own aspirations, to your own goals and dreams. And then you could end your application, or you could sum all of these up by explaining how, if you were to become a software engineer graduating after the course, how would you help change the world in your profession? So if you think big, if you look far ahead in the future, what would you be able to do, and what would you want to do to make a difference as a software engineer? All of these things put together would make for a very strong, passionate personal statement that would differentiate you from other applicants. And the last thing, and the most important thing, you have to believe in yourself. You have to be confident that you can do it. You can study software engineering because that's the thing you want. And if you believe in that, then it will happen. So if you graduate from a software engineering course, as I said before, there's no sector where you wouldn't be able to be employed. But some examples of organizations that are linked to software engineering: you have Microsoft, you have IBM, you have Oracle, companies that are based on software. So the vast majority of their operations revolve around software. But then you would have companies that use software as a means to an end. So you have Vodafone, you use software to power telecommunication; HSBC, software behind banking; the BBC, software behind the media. So you would have all those opportunities at your disposal with a degree in software engineering. And the different roles that you can get into, apart from the obvious one, software engineer, developer, or architect, you could be a systems analyst, meaning your role is more about understanding what the client wants and less so about building the solution. There is different aspects to software that require different skills. So you have a front-end engineer who looks at the user interface and how the user interacts with the software. You have the back-end engineer who is looking at the data behind the scenes and how they feed into what the user sees. And then you have a full-stack engineer who is skilled at both sides. They are equally capable to work with interfaces as they are with databases. You also can work as a quality assurance engineer, anything that has to do with testing and maintenance, project manager, or technical consultant, going into businesses who are in need of someone with software engineering knowledge to improve their operations. So with all of these roles, you definitely can understand that it's easy to be employed as a software engineer. And actually statistics show that 90% of computer science graduates in general across the UK are employed or in further study after the degree. In terms of income, while the average graduate income in England is £27,000, you will be looking at more than that. So in a digital technology occupation, which includes obviously software engineering, you would be looking at a median salary of £35,000, for example, in Yorkshire and the Humber. In other regions, it might be even higher. So it's a quite well compensated profession. And you have to take into account that in recent years, especially during and after the pandemic, employment in technology occupations like software engineer and others has grew substantially. So these numbers here are already outdated in the sense that this is before the pandemic. And before the pandemic, there was a growth of 40%, so 3 more million jobs created in technology employment. Now, this is even more. As you can imagine, a lot of tasks now depend more heavily on software engineering because they have moved online. So in total, you see that there is a strong, high increase in demand for roles with skills that a software engineering course is offering to you. So it wouldn't be, a guess to say that if you go into software engineering, it's very, very likely that you not only will be employed, but you will have a very good salary and great career prospects for you. But at the same time, you will be able to drive change in the world in whatever application that your software is going to be involved in. And that's it from me. I would advise you to look into different options for software engineering. There are many different courses across the UK. And if you do choose to go on to this course, I hope you enjoyed it, and I hope that it helps you realize your dreams.